This is the real Australia. The grazing lands, the streams, the musterers and the sheep themselves, all combining to give the country a natural beauty and at the same time contributing largely to the bulk of the national wealth. Stud breeders have developed sturdy and healthy stock since the days when the first sheep were imported, and rams such as this fellow have built up the great flocks that graze the vast sheeplands of this country. Constant experiment and research have improved the quality and increased the quantity of wool produced here, but still the grower, stud breeder and scientist persist in their efforts to further improve wool's natural superiority as a textile fibre. At an international wool textile conference held recently in Australia, scientists from all over the world met to discuss progress already made in the fields of textile research. Progress which has undoubtedly played an important role in reducing the cost of production and improving the quality of wool. At the conference, men such as Sir Ian Clunies-Ross of Australia talked earnestly about their problems and methods of overcoming them. Men of science meeting to gain a greater knowledge of improving the efficiency of wool processing through a better understanding of the structure, chemical composition and physical characteristics of the wool fibre. Many of the delegates have worked in separate fields of scientific and technical developments, and everyone is keen to pool the findings and discuss them for the mutual benefit of all. Throughout the world, the advances made by these scientists will quicken the pace in research and add to the growing number of industrial processes being used in giving consumers better quality and a greater variety of wool fabrics. One of Australia's wool textile research laboratories is located at Geelong in Victoria, and here the testing of basic research results obtained at other centres is carried out, as well as the development of new and improved textile processes. Raw wool contains swint, wax and other impurities, and where previously it had to be scoured with soap and alkali, the Geelong scientists have found a method of continuous washing in spirit, which causes none of the fibre damage that went hand in hand with the old system. In the new process, dry cleaning fluid is sprayed through the wool, and all the fat, grease and other impurities are washed away. The force of the sprays, which are set at an angle, turns over the wool and so eliminates a great deal of the felting which normally occurs. After the dry cleaning fluid is sprayed through the wool, clean water is then forced through at high pressure and the wool is conveyed to the dryer. The development of this degreasing process has meant a considerable increase in the efficiency of scouring raw wool and a great deal of saving in both time and money. The pilot plant at Geelong occupies only half the space that would be required for a normal type scouring plant of similar capacity. The staples have remained intact and clean and will give a greater yield of wool top than normally scoured wool. The cleaning fluids used go into settling tanks and are then recirculated through the system. Valuable byproducts such as lanolin are drained off into drums for use commercially. The dirt, which has been taken out of the wool, is removed from the tanks, and as it may have some use as a fertilizer, it can be put back into the soil to help grow more wool. Nothing is wasted here. A most important section of the research laboratory is the standards room, where fabrics and fibres are given tests to determine their wearing abilities. This abrasion testing machine will give the scientist valuable knowledge of the wearing capacity of different fabrics. The eccentric movement of the machine ensures that the pieces of fabric being tested will be rubbed in all different directions. Just as this fabric bursting machine measures the resistance of various materials, so this fabric tearing machine measures the strength required to rip cloths under a pressure far greater than would be met in normal usage. This yarn testing machine measures the breaking strain of different lengths of yarn from the same parcel, and the strength of each thread is plotted on a chart. As the yarn is broken, an arm comes around automatically and stretches the next piece of thread ready for testing. On this machine, the breaking strain of lengths of yarn is measured separately. As the weight tilts over, the yarn breaks and the strain is recorded. Another abrasion testing machine is prepared, and this machine works in a to and fro motion. The severe tests given to fabrics and yarns in the standards room are supplying scientists with a great deal of new information on the wear and tear resistant properties of wool. An outstanding achievement at Geelong was the development of C.I.R.O mark branding fluid, a fluid which has almost eliminated the troubles caused by the use of tar and paint brands. C.I.R.O mark has enabled Australia's wool clip to be marketed as being free from brand damage, and this has meant the saving of many thousands of pounds to this country. From C.I.R.O mark to C.I.R.O fix, a new discovery that stops woolen fabrics from shrinking in any way, even after long periods of washing. The top half of a sock is dipped in C.I.R.O fix, a solution prepared from the synthetic resins of nylon scrap, an example of how scientific research can use the competing synthetics to further advance the qualities of woolen fabrics. The sock is put through a wringer so that any excess fluid will be squeezed out. C.I.R.O fix is already being used commercially in shrink-proofing woolen goods. The treated sock goes into a washing machine for a really hard wash that's going to last 2 hours. It's 10 to 2. And the sock will be swirled around in the suds by the machine where any normal fabric would lose its shape. But the fibers of this sock have been welded strongly together by quite a simple process. The 2 hours is up, and the scientist takes the sock out to check results. To prove the formula in theory is one thing, but to prove it by exhausting tests is the final goal of the scientist. The sock will be placed alongside the other one of the pair to check on the size. And the difference is obvious. The top half of the treated sock is still as new, but the untreated foot of the sock has been badly shrunken. A look through the microscope will show how this new anti-shrink fluid works to prolong the life of fabrics. The red spots show where the C.I.R.O fix has welded the fibers together. This chemical solution, which now makes it possible to put almost permanent creases in wool fabrics, is another outstanding achievement of the wool textile scientist. This method of durable creasing is called the C.I.R.O set process. We shall see how it is applied. One leg of a pair of trousers is sprayed with the chemical solution, and the other leg is left in its normal state. Although it's necessary only to spray the solution along the trousers where the crease is to be formed, the general appearance of the garment is greatly improved by spraying the solution over the whole leg should the garment be wet by rain. Tests covering a wide range of fabrics have shown that the solution used in the C.I.R.O process causes no colour alteration or staining of the fabric. When the spraying of the test leg has been completed, the trousers are taken to be pressed. Pressing is carried out in the normal way. First one leg is pressed and then the other. However, any garments that have been treated with the C.I.R.O process must be left in the press with the steam on for 15 seconds. This ensures that the steaming action of the press will allow the solution to set the crease correctly. Great care has to be taken in forming the crease because once it has been formed, it cannot be removed with ordinary pressing. The trousers are left in the closed press until they're quite dry. In order to test as severely as possible the durability of the crease obtained using the C.I.R.O process, the trousers are placed in this industrial washing machine, which has been filled with soap and hot water. Of course, trousers normally would not be given this treatment. Tests carried out over many months have shown that continual wetting by rain has no effect on the creases, and wool fabrics that have been dry cleaned many times also showed no signs of losing any creases formed by this process. The trousers are removed after being tumbled around in the machine for over an hour, and as you can see, they've been thoroughly washed. The trousers are then placed in another machine for rinsing before being finally spun dry. After being dried and aired in the drying cabinet, it can be seen that the crease on the leg that was treated with the C.I.R.O solution has remained sharply defined, but the leg that was not treated has entirely lost its original normal crease. The development of this durable creasing process will add greatly to wool's other natural advantages as a textile fibre. Although satisfactory methods for moth-proofing wool have been known for many years, the cost of treatment has greatly curtailed the use of these methods. After intensive research work, scientists found that the insecticide dieldrin, which had come into general use against various stock and plant pests, was a most effective and inexpensive moth-proofing agent. Even after severe washing, dry cleaning and weather exposure tests, fabrics that had been treated with very low concentrations of dieldrin remained markedly resistant to moths. At Geelong, work has been carried out to test the efficiency of dieldrin against carpet beetles. But as you can see, the beetles have made no attempt to chew the piece of treated material. This scientist is checking the tests being carried out with moth larvae on dieldrin-treated fabrics. The damage done by the moth larvae can be seen on this piece of untreated cloth. The grubs certainly have had a good feed here. But now a treated piece of material and an untreated piece are placed together. The larvae will not touch the treated material. Another interesting experiment being carried out at Geelong is the work being done to test the merits of rugging sheep. As you can see, the fleece on this sheep, which has been rugged for 12 months, is clean and well grown. When the wool is opened up, it is found to be clean with a very light tip. There is no dirt in the fleece, and these sheep have been run in fairly dusty country. The wool on this unrugged sheep, however, shows the normal heavy tip, and the fleece is stained and dirty, and these sheep have been run together on the same property. Staples from the fleeces of both sheep clearly show the differences in the wool. The staple from the rugged sheep on the left compares more than favorably with the wool from the unrugged sheep. The recovery of wool wax from scouring fluid has been greatly increased by researchers at Geelong. The fluid is fed into a battery of cells fitted with high-speed stirrers which concentrate the wax on the surface of air bubbles. The froth is then transferred through the cells and the wax is floated off into a drum ready for commercial use. This pilot machine was developed in the Textile Research Centre at Geelong for research on melange printing. Slivers of wool are put through the machine, which prints a broad dyed line diagonally across the sliver. The dyed sliver is then taken and placed in a small steam chamber where it will be kept under a pressure of 15 pounds per square inch. The sliver will be left in the chamber for 10 minutes in order to fix the dye properly. One of the features of this method of melange printing is the greatly reduced time required to fix the dye in the sliver. Wool treated in this way is used in melange suitings. The fixed sliver of wool is taken out of the steam chamber to be dried and tested. In order to test fastness of the dye, the sliver is dipped into a dye testing fluid and it is seen that the dye remains fast in the wool. Teasing out the sliver shows the effect achieved when it is spun and woven into a finished fabric. The problems of wool textile processing can be studied under actual working conditions at Geelong, where an experimental mill has been set up to carry out pilot-scale trials. Here, the most up-to-date machines have been installed so that the whole processing of wool textiles from the raw material to finished fabric can be observed. The efficiency of any new developments in manufacturing processes are studied and the results passed on to industry. The establishment of this pilot mill affords scientists an opportunity of understanding the problems associated with textile manufacturing, and at the same time it provides a means of applying in a practical way methods of overcoming these problems. Striking advances have been made over the past decade in wool research, shrink-proofing, moth-proofing, permanent pleating and many other developments in wool processing, developments which are now accepted mill practices. And it is here in the mill that the benefits of all the time, money and effort spent on research are finally realized. As the machines weave the intricate patterns of new cloths which go out to clothe a world that is always demanding better fabrics and finer fabrics, we think of the wool scientists who are working today as never before in almost every country in the world, working to enhance the already superior qualities of wool as a textile fibre. With a better understanding of the fibre itself, wool researchers have been able to use the natural advantages already possessed by wool to further improve its versatility. The benefits to be gained from introducing new manufacturing processes which have already been developed by wool research workers have been acknowledged by the textile industry, and by their use, processing costs can be lowered with a resultant benefit to all. These new cloths coming off the finishing lines emphasize the value of research, for to wool's affinity for dyes, its ability to withstand heavy wear and its natural elasticity have been added the benefits of moth-proofing and shrink-proofing. Wool that is crease-resistant, warm and durable, being produced in a wider variety of textures and colors as a result of the painstaking, laborious work of the wool textile researcher. Wool faces a new future, a future of expanding research, with wool scientists from many parts of the world all working to develop practical methods of improving and increasing the uses of wool. The scientist, with his ever-inquiring mind, his microscope and test tubes, already has a greater understanding of the structure, composition and character of the wool fibre, a fibre which is almost as old as man himself. While the scientists and research groups keep working to produce the best available materials to clothe and warm the people of the world, the primary wealth of a nation moves picturesquely around its grazing lands. Modern science working hand in hand with wool growers who have been tending their flocks for centuries. And with the wider knowledge already gained, the wool research scientist continues his investigations to further the progress of wool.